Good evening, guys. Am I audible?
Yes, sir.
Yeah. Shall we get started? So, is there any doubt from the previous topics that we discussed? Is everything clear? Right. So, I am assuming that everything is clear, right? Okay. So, we'll move on to the next topic, that is the theorem of total probability. Right. So, before that, I need to discuss about the partition of a sample space. Right. So, today we are going to discuss about a rule or a theorem called as Bayes theorem. Right. Now, let's see. So, what is a partition of a sample space? See, suppose you have a set of events, E1, E2, so on till En, which are coming from the sample space S. So that if I say that you take any two events and the joint, that is the intersection between these two sets is null set. And if you take the union of all these events and it gives you a sample space, then what can you say? So if two events have intersection equal to 0, what can you say about them? They are mutually what? They are mutually exclusive. Right? Similarly, if the union of all the elements put together is a sample space, then they are said to be exhaustive. Right? And if the probability of each event that you take is greater than 0, which is a non-zero value, when you have this kind of a partition, let all these things be a partition of the sample space. And suppose that each of the events E1, E2 till En has non-zero probability of occurrence, that is greater than 0 value, then let A be any event associated with the sample space. Then what you can say is, probability of that particular event A to occur, you can write it in terms of mutually exclusive and exhaustive events as probability of E1 into probability of A given E1 plus probability of E2 plus probability of A given E2 plus so on till probability of En plus probability of A given En. So all put together, you can write it as sigma I or j, whatever you want, you can take it. I is equal to 1 to n probability of event I into probability of A given event I. Okay, this is what is called as the law of total probability. This is also called as law of total probability or theorem of total probability. Right? So based on this, we are going to see a theorem called as Bayes theorem. Suppose if I take the events E1, E2, so on till En are n non-empty events which constitute the partition of the sample space, then they are pairwise disjoint, means they are mutually exclusive and they are exhaustive. Okay, if these two conditions are simultaneously satisfied, then if you take any event A which is of non-zero probability, then what you can say is probability of EI given A is equal to probability of EI into probability of A given EI divided by the sum of the values. So sigma I is equal to 1 to n probability of EI into probability of A given EI. I'll tell you how to solve problems. You take any problem How are you supposed to apply this? I'm going to explain it now. Okay. Right. So having this in mind, let's try to solve a problem. So example number 16. So there is a bag one which contains 3 red and 4 black balls. Okay. While there is another bag 2 which contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and is found to be red. Find the probability that it is drawn from bag 2. So how to solve this? One of the ball is drawn at random from one of the bags and it is found to be red. Right. So here the question is, one of the balls is drawn at random from one of the bags. Before even you take the ball, the first task that we are supposed to achieve is you need to pick the bag. Right. Let's say E1 be the event of choosing bag 1 and E2 be the event of choosing bag 2. Now tell me one thing. What about E1 intersection E2 and what about E1 union E2? So what can I say about the intersection of event 1 and 2? Guys, answer this. So picking bag 1 is the event 1 and picking bag 2 is event 2. What is the intersection between these two? Are they dependent events or they are not dependent on each other?
I think they're not dependent on each other.
So what can I write? E1 intersection E2 is null set 5. And E1 union E2 is, you can either choose bag 1 or you can either choose bag 2. Are they not exhaustive events?
Yes, sir, they are.
So it is equal to sample space. So if you see these two events which are coming from the sample space are mutually exclusive and exhaustive. Right. Now what they are saying is, now the task is one ball is drawn. So I will assign event A as drawing a ball. But is there a condition? One ball is drawn at random from the bag and it is found to be red. So event A is about drawing a red ball from the sequence of these events. So what is the probability that it has come from bag 2? So what is the probability that you have chosen bag 2 knowing that the red ball has come from there is equal to what? That is what the question is. Okay, even before you frame anything, you start solving, you first need to define the events. Okay, the events which you are defining are supposed to be exclusive and exhaustive. So here there are two events, so I wrote E1 and E2. Right. So what is probability of E2 given A according to the formula of Bayes theorem? What is probability of E2 given A according to Bayes theorem? So it is probability of E2 into probability of A given E2 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Now is it not easy for us? So you have defined E1 as choosing bag 1. Then what is the probability of E1, guys? So how many bags are there? 2 bags. Out of the 2 bags, you have 50% chance. That is 1/2 chance to choose bag 1. Similarly, here you are choosing bag 2. So what is the probability of E2? That is also half. So they are said to be equally likely outputs. So we got the value for E2 and E1. Correct? Huh? Now what is our job? What is the probability of A given E1? What is the meaning of this? What is the probability of you choosing a red ball known that it has come from bag 1? That is how much? 3 out of 7. What is the probability of A given E2? What is it? 5 out of 11. So you have all the values. Now what are you supposed to do? Take this and substitute it in the formula and you will get the required answer. Guys, am I clear? Guys, am I clear or not?
Yes, sir.
No. Okay. So substitution part, I'm assuming that you guys will do it. Now I'll do few more examples to explain you. If you guys can discuss with me, it will be much better. Try to have as much discussion as possible. If you have any questions, ask. See, 17th. You are given 3 identical boxes, 1, 2, and 3. And each contain 2 coins. In box 1, both are gold coins. So box 1, 2 gold coins. I'm just collecting the data in my own language. So it contains 2 gold coins, and box 2 contains 1 silver, 1 gold, and obviously box 3 will contain, oh sorry, box 2 contains 2 silver. Box 3 contains 1 silver, 1 gold, right? So a person chooses a box at random. So there is a person who's choosing a box at random and takes out a coin. If the coin is gold, okay, what is the probability that the other coin in the box is also of gold? So tell me, how many events am I supposed to define for this question? So what is the sample space here? Sample space is all the 3 bags are there. So from all the 3 bags, if I take event 1, then what will I define that event 1 as? Event 1 is choosing box 1. What about event 2? Choosing box 2. What about E3? Choosing box 3. Correct? So what is the event A associated along with this? If the coin is gold, what is the probability that the other coin in the box is also gold? So event A is coin drawn should be gold, and what is the probability that the other coin in the box is also of gold is the conditional probability. So what am I supposed to find? What is the probability of E1 given A? Is that right? Right? So that will be probability of, so what is it, guys? Probability of E1 into probability of A given E1 divided by sum of probability of E1 into probability of A given E1. So what is the probability of E1, probability of E2, and probability of E3? All the 3 are likely to occur. So it is 1 by 3. There is a 33% chance for you to choose any one of the bags. So what is the probability of choosing a gold coin from E1? What is the probability of you choosing a gold coin known that it is from bag 1? Let's see how many of you are able to answer. So bag 1 contains 2 gold coins. Out of the 2 gold coins, if I ask you to pick one of the gold coins, pick one gold coin, what is the answer? You have 2 gold coins, sir. From those 2 gold coins, I'm saying pick one of the coins and I want that one coin to be gold. So how much is the
1?
It is a sure event. It is 1. What is the probability of A given E2?
0.
0.
What is the probability of A given E3?
1 by 2.
1 silver.
1 by 2.
It is 50% chance. Take all these things and substitute it in the formula that will give you the answer. But are you guys able to understand how to apply this theorem? That is more important for me. Will you be able to collect the data properly? Yeah. So this is also a good problem. In a factory which manufactures bolts, there are three machines. Machine A, B, and C manufacture respectively 25%, 35%, and 40% of the bolts. So first, even before you proceed, since it spoke in percentage, the sum of all the three should give you 100. Check that. 40 plus 35, 75 plus 25 is 100. So 100% is produced only from these three machines. Okay. Of their outputs, 5, 4, and 2% are respectively defective bolts. Now, what they're doing is a bolt is drawn at random. Okay. A bolt is drawn at random from the product and is found to be defective. What is the probability that the defective bolt is manufactured by machine B? Right. Now tell me. So, what are the points you are supposed to write as events? So, I will take event one. I'll go with the same notation. Okay. So, what is event one? Bolt manufactured by machine A. What about E2? Bolt manufactured by machine B. What about E3? Bolt manufactured by machine C. Okay. Now, what is the event? A bolt is drawn at random. Okay. So, what is the event A that we are going to write here? A bolt is drawn at random from the product and is found to be defective. So, A is about choosing a defective bolt. Now, according to the question, what is the probability? What is the probability that it is manufactured by machine B? So, you know that it is manufactured by machine B and it is a defective bolt. Right? What is the probability of E2 given A? What is it? So, probability of E2 into probability of A given E2 by sum of all these things. E2 into probability of A given E2. So, what is probability of E1? Tell me. What is the probability of the bolt being manufactured by machine 1? They have already given the answer. 25%. 25% is, yes, 25% is 1/4. What is the probability of E2? 35%. That is 35 by 100. How much is it? 7 by 20. Yeah.
20. So, yes, sir.
So probability of E3 is how much? Yeah. Probability of E3 is 40%. So
2 by
40 by 100 means it is divisible by 1 by 5. 1 by 5.
2 by 5. 2 by 5.
Yeah. 2 by 5. Yeah. So 2 by 5. What is the probability of A given E1? Meaning of this is, what is the probability of you choosing a defective bulb known bolt that it has come from machine 1? That is how much?
Five by 100. Right?
So it is 5, no? It is 5%. 5 by 100, which is 0.05. What is the probability of A given E2? 4. No. 4%. That is 0.04. What is the probability of getting a
2
defective
by
bulb
100.
from 2 by 100, which is 0.02. Right? Take all the values and substitute it here. That will give you the answer. I wrote a formula, right? Substitute it here. That will give you the answer. Right? This is the only procedure to solve the problem based on Bayes' theorem. Shall we do one last problem?
Yes, sir.
So I'm assuming you would have already learned this in school. Right. 20th. So this is also an interesting one. A doctor is to visit a patient. From the past experience, it is known that the probability that he will come by train, bus, scooter, or by other means of transport are respectively 3 by 10, 1 by 5, 1 by 10, 2 by 5. So each is an event. So he coming to the hospital is for sure. If he comes, he can either come by train, bus, scooter, or means of transport. So they have given the probability of each. And if you add all these values, what do you get? So 3 by 10 plus 2 by 10 plus 1 by 10 plus 4 by 10. 3 plus 2, 5, 5 plus 1, 6,
1.
6 plus 4, 10. You get
1.
1. You get 1. So with the probability of all the events put together is 1 means all these events are said to be exhaustive. Secondly, if he comes by train, he can't come by bus or scooter or any other means. So he can come only in either of the transport. So all these events are mutually exclusive also. So can I think of applying Bayes' theorem? Right? So the probability that he will be late are 1 by 4, 1 by 3 and 1 by 12. If he comes by train, bus or scooter, and if he comes by other means of transport, then he will not be late at all. When he arrives, this time he is late. What is the probability that he comes by train? So what is event 1? Event 1 is he coming by train. Event 2 is he coming by bus. Event 3 is he coming by scooter. And event 4 is other means. Correct. Then what is the event A? What is event A? He's coming late. Right. What are we supposed to find? To find this, what is the probability that he comes by train knowing that he is late? So what is the probability that he came by train knowing that he is late is equal to how much? So what are all the required data, guys? P of A into P of E1, sorry, P of E1 into P of A1, E1. E given A to all these things you need to find. So what is the probability of event 1? They have given it 3 by 10. Probability of event 2, they have given it 1 by 5. Probability of E3, 1 by 10. Probability of E4, 2 by 5. Correct? Now the question is, what is the probability of A given E1? It is 1 by 4. What is the probability of A given E2? That is 1 by 3. What is the probability of A given E3? That is 1 by 12. And what is the probability of A given E4? So what is the probability he is late given that he comes by other means of transport? So he will not be late at all. So answer will be 0. Now you got all the values. Will you be able to substitute and find the answer?
Yes, sir.
Yeah. So that's it, guys. So this is how you apply Bayes' theorem. I'm expecting you to solve these problems. Okay. You have any doubt, you can reach out to me. I'll discuss the next exercise also. This is the last part, no? Random variables and probability distributions. So let's get to this concept. Right. So this is about probability only. Only thing is we are introducing little bit of statistics into probability. That is why this exercise is important. Okay. So you're just assigning the same probability in a more organized and a mathematical way. That's it. So we have already learned about random experiments, right? And the formation of sample spaces. We know all these things. In most of these experiments, we are not only interested in the particular outcome that occurs, but rather in some number associated with the outcome as shown in the following examples. Suppose in tossing 2 dice, we may be interested in the sum of the numbers on the 2 dice, right? That might be a case. Suppose you have an experiment where you're tossing a coin 50 times. We may want the number of hits that are obtained in those 50 tosses, right? So all these things are there. Similarly, in an experiment of taking out 4 articles, one after the other at random from a lot of 20 articles in which 6 are defective, we want to know the number of defectives in the sample of 4 and not in particular sequence of defective and non-defective articles. Okay. So when you have all these things, then what we can do is we can assign all these numbers to a variable, which we call it as a random variable. That is what we will discuss. In all the experiments, we have a rule which assigns to each outcome, the experiment, a single real number. So if you're able to give a single real number to each outcome that you're trying to talk about, where it may vary with different outcomes of the experiment, since it is a variable, also its value depends upon the outcome of the random experiment, it is called as random variable. So generally, when you take a random variable, it is denoted by the symbol X. So this is the theoretical part. Let's not worry much about it. Let's take an example to understand this. Okay. So before that, let me read this point also. If we recall the definition of a function, you will realize that the random variable X is really speaking a function whose domain is the set of outcomes or sample space of a random experiment. So if you take a random variable, it can take any real value. Therefore, its codomain is the set of real number. Hence, random variable can be defined as follows. So we are going to take, as I told you, we are going to take a random variable and assign it to that particular probability to make our things in a more sequential and a methodical order. Okay. Let's get to that point. So let's see what is the definition. If you talk about a random variable, it is a real valued function whose domain is a sample space of a random experiment. Okay. So let us consider an example of tossing a coin 2 times in succession. So tossing a coin 2 times in succession is the same as tossing 2 coins at the same time. Right? Then what is going to be the sample space of the experiment? It will be head, 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 tail, tail, tail. Sorry, tail, head, and tail, tail. Suppose I am assigning a random variable x, where this x speaks about the number of heads that are obtained. Okay, so x is a variable where I'm interested to know how many times heads has occurred in each point from the sample space. Then what I can say, first element is there. No, if I write a random variable x and write h, how many times has head occurred in this particular sample point? It is 2. Similarly, if I give a random variable for head tail, then how many times has head appeared? It is 1. Similarly, if I take tail head, it is again 1, and if it is tail tail, it is going to be 0. Right. So what is the range of these values? It is between 0 to 2. Right. Similarly, you can ask me a question. Can I define multiple random variables for the same experiment? Yes, you can do that. So more than one random variable can be defined on the same sample space. For example, let's say y denote the number of heads minus the number of tails for each outcome. So you are giving a mathematical statement, right? You're talking about, I want to find the number of heads minus the number of tails in each outcome. And I will say that variable as y, means you're collecting the data. You're trying to place it in a sequential order. As I told you, this random variable is about the statistical probability that is happening. Means you're collecting the data of each outcome and you're placing it in a sequential order. So what is YHH? So what I'm trying to say, number of heads minus number of tails. So number of heads are 2 minus the number of tails are 0. So Y is 2 here. Similarly, YHT is 1 head minus 1 tail, that is 0. YTH is 0. YTT is minus 2. So if you observe, the random variable is coming out to be negative also. The definition says no. Is a real valued function whose domain is the sample space of the random experiment. Okay. So first what we are going to do is we are going to learn how to assign random variables to a problem that is given. First, let's get to that point. So if I take this example 22, you guys are going to tell me. So there is a person who plays a game of tossing a coin thrice. So when tossing a coin thrice, what are the outputs? Head, 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 tail, head, tail, head, tail, head, 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 tail, 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 head, tail, TTH, and triple T. I hope everybody knows how to write this. Head, 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 tail, 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 head, head, tail, tail, head, head, tail, tail, head, tail, head, tail, head, tail, head, tail. If you take everything and put it there, you'll get it. For each head that he gets, he is given ₹2 by the organizer of the game, and for each tail, he has to give ₹1.50 to the organizer. Let X denote the amount gained or lost by that person. Show that x is a random variable and exhibit as a function on sample space of the experiment. So if I take x of head, what will I get the answer as? So random variable x says the amount gained or lost. Okay. The random variable for 3h is how much? Getting 3 hits successively. So what will happen? Is he paid money or he has to pay money? So he is paid is 2. So what will be the answer? So what will be the answer? It is going to be rupees 6. So random variable for head, tail. So for 2 heads, he gets 4 rupees. And for 1 tail, he loses 1.50 rupees. So answer would be rupees 4 minus 1.5 is going to be 2.5. Similarly, x, h, same thing, x, t, h. It's the same thing. What about x, htt is the same as x, tht is the same as x, tth is equal to how much? 2 tails, he is losing 3 rupees. 1 head, he is gaining 2 rupees. So 2 minus 3 is minus 1. And x, ttt is how much? He is losing 4.5 rupees. So if I take this x, right, and I write it in the form of a set, then what is the range of values that are possible for this random variable? So it is minus 1. It starts with minus 4.5. Minus 4.5, minus 1, 2.5, and 6. Is it clear? Did you understand how to assign the random variables? Yes or no? Okay. Next is, I'll go to the probability distribution of a random variable. Means, if you take a random variable x in the system of numbers, let's say x is equal to x1, x2, so on till xn, we will be writing the corresponding probability for that and put in a table. So probability of each random variable, let's say, probability of x1 is p1, probability of x2 is p2, it keeps on going like this. Then this kind of a table is what we call it as probability distribution table. Let me take an example and explain it. So 2 cards are drawn successively with replacement from a well-shuffled deck of 52 cards. Find the probability distribution of the number of aces. Okay. So 2 cards are drawn. When 2 cards are drawn, how many aces are there in a particular set of cards? In a particular deck, how many aces are there? How many aces are there in a deck of cards?
4, right?
Yeah, 4. Out of the 4, how many cards are they choosing? So 2 cards are drawn. So when 2 cards are drawn, what is the possibility of you getting ace? What are all the random variables you can assign to an ace? So out of those 2 cards, both the cards
0,
need
1
not
or
be.
2.
Yeah, 1 card can be ace or 2 cards can be ace. So x is equal to 0 is there, no? So x1 is 0. So what is the probability of you getting x is equal to 0? So how many non-ace cards are there? Here, if you observe,
48.
two cards are drawn successively with replacements. So you're 52 in the first draw. You're replacing the card again, and you're taking card with 1 divided. Prepare like this: X and when 0 ace is coming, what is the probability associated with it? 144 divided by 169. Similarly, what can happen? You can have 1 ace. So when you have 1 ace, what will happen? Let's say you are getting 1 ace in the first draw. When you're getting first ace in the first draw, you will get 4 divided by 52 into 48 divided by 52. Or, why am I putting an or here? Because there is a possibility of you getting this ace in the second draw also. Here the sequence is also important. 48 out of 52 into 4 out of 52. So most people, what they do is they forget to put this plus. They think this is the only case, because order is also important here. When that is the case, you get the answer as 24 divided by 169. So four 52 second draw also going to be 1 by 160. So 1 by 13 into 1 by 13, which is 1 divided by 169 to 1 divided by 169. Did you understand? This is what is called as probability distribution table. Means you prepared it, right? This table is what is called as the probability distribution table. Like you would have learned these things in your statistics, right? Frequency distribution table, something like that. Similarly, here we are trying to talk about probability distribution. Clear? So I'll do one more problem based on this, then I'll move on to the other statistical part. Find the probability distribution of number of doublets in 3 throws of pair of dice. So if I take X as the number of doublets, and how many times is the dice thrown? It is thrown 3 throws of pair of dice. Okay, 3 times those dice are rolled. How many dice are there? Pair of dice. So what will be the outcome? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Right? These are going to be the variables. Right? So what can X take? So what can X take?
0, 1, 2, 3, because 3 times you're drawing it, right?
Yes. So first time you can get 0, 1, 2, or 3. So if I put the table X and probability of X, 0, 1, 2, 3, what is the probability of you getting 0, this thing, doublets? So probability of getting a doublet is, what is the probability of getting a doublet? 1, 2, 3, 4, 5, 6. 6 out of 36 outcome because 6 square. Yes. Yeah, it is 1 by 6. Probability of no doublet. Obviously 1 minus
5 by 6.
5 by 6. Yeah, just give me a second. My pencil stopped working. Just give me a second. So no doublet is 5 by 6. So what will be the answer for P of X is equal to 0? So first time, no doublet. Second time, no doublet. Third time, no doublet. So what is the probability is equal to 1? This is what the tricky part is. First time you can get a doublet, second time and third time you will not get a doublet. Or first time you will not get, second time you will get, and third time you will not get. Or first time and second time you will not get, but third time you will get. Did you understand what I wrote here? So what about the probability distribution, probability value for x is equal to 2? You guys tell me. First time you can
1
get,
by 6
second time you can
into-
get, third time you will not.
Yes.
1 by 6 to 5 by 6, or 1 by
Same
6
thing into
into
3, right?
5 to 1 by 6, or 5 by 6 into 1 by 6 into 1 by 6. Correct?
Yes, sir.
Right? Is there anything that? Yeah. So what is the probability of x is equal to 3?
1 by 6 into 1 by 6 into
Getting
1 by
doublet.
6.
So 1 by 6 into 1 by 6 into 1 by 6. So you will get the values, right? Take all those values and put it under this value. That will give you the required probability distribution table, which is this thing. I hope I'm clear with this, right? And if you observe, no, the sum of all probabilities should give you a 1. Right? Let's do this problem because it is something related to functions. After this, I'll go to the mean of random variable. Then I'll go to the variance. And with that, we'll be done.
Sir,
Yeah, Nima.
Sir, I think we have deleted portions from this chapter. The mean and variance of random variable and binomial probability distribution is deleted.
Please put in the chat box. Mean and variance is deleted. Correct. Are you guys able to hear me?
Yes, sir.
I think mean and variance is deleted. Yes. So you have Bayes theorem, random variable, and probability distribution. If you know the distribution table, that is enough. Yeah. So is there did they teach in your school? If they have taught, I will explain it. That is why I'm asking.
No, for me, they didn't teach.
They didn't teach, right? Because it's not there. I just checked. I just compared with 2018-19 syllabus. There it was there. Mean, variance, random variable, and Bernoulli's distribution is there. Now you have only random variable and probability distribution. So I think we are done, right? So it's a simple part only. Then we'll do this problem with that. I think the syllabus is over. Let X denote the number of hours you study during a randomly selected school day. The probability distribution that X can take the values X has the following form. So probability of capital X is equal to X is 0, kx, k into 5 minus x, or 0 otherwise. Find the value of k. Okay. So X denotes a number. So you can either study 0, 1, 1 or 2. Then for us, doesn't happen. So that is because it is a school day. So find the value of k means these are all the probabilities. Sorry. These are all the variables. So if I have to put it in a probability distribution part, X is equal to, so X is taking 0, 1, 2, 3. When X is equal to 0, what is the probability? You 1 here, it becomes k. 2, put 2 here, it becomes 2k. X is equal to 3, 2k. When equal to 4, put 4. So I told them put the probability from the distribution table. What is it? Sum of all the probabilities is equal to 1. So if you add everything, 2k, 4k, 5k, 6k. So 6k plus 0.1 is equal to 1. So 6k will be equal to 0.9. So k will be equal to 9 divided by 60, or how much is it? Or I can say 9.9 by 6 itself, it will be 0.15. So the value of k is 0.15. What is the probability that you study at least 2 hours? When I say at least 2 hours, you can study either 2 hours, 3 hours, or 4 hours. So you add every probability. So k value is 0.15. So when k value is 0.15, 2 hours means it is 0.3. 3 hours means 0.3. 4 hours means 0.15. If you add all the 3, what will you get? You will get 0.75. So your probability of you studying at least 2 hours is 0.75. Exactly 2 hours is this thing. How much is it? 0.3. So exactly 2 hours is 0.3. And at most 2 hours means 0, 1 or 2. So it will be 0.1 plus 0.15 plus 0.3. So 0.45 plus 1. It is 0.55. Right? Am I clear, guys?
Yes.
So that's it. So this exercise also you guys can solve. So you can ignore the problems based on statistics. Your work is only to know how to form the probability distribution, right? So with this, we can say that the syllabus is over. Okay, now it is your turn to start preparing. Okay, start working on all the problems. If you have any doubts, reach out to me on the student support number. And you will get an announcement for the test dates. So when will the test start and when will each chapter be conducted and all those things, okay? You will get the schedule in 1 or 2 days. So is there any other doubt?
No doubts.
So that's it, guys. That's it from my side. Okay. No doubt we can wind up. That's it. You can read.
Thank you, sir.
Thank you.
Thank you, sir.